All right, here we go. Solving quadratic equations through a variety of different methods. And I want to start with one that's actually not on your notes. If we have 3x squared plus 12 equals 0, notice there's no b value. There's no plus x. It really is plus 0x if you want to think through it in that way. Um, but how would we solve this? And well, we would solve probably by taking the square root of both sides. So let it set it up for that. We end up with, if I subtract 12 from each side, we're going to get 3x squared equals negative 12. Divide each side by 3. Have x squared equals negative 4. And take the square root of each side. That would leave us with x is equal to positive or negative, the square root of negative 4 is going to give us 2i. And so you could either write it plus or minus, or that it's negative 2i and 2i. X is equal to negative 2i and 2i. And that right there, that method's going to help us out in a couple of different problems. So let's take a look at A, kind of just now that we have refreshed ourselves just on basically taking the square root to solve a quadratic equation. So this one's set up right away for taking the square root. We already have something squared right here. And so to get start getting x by itself, we're going to take the square root of each side. That leaves us with the radicand in here. So 2x minus 1 equals plus or minus 2i, just like we saw a second ago. The square root of negative 4 is 2 times the square root of negative 1, and square root of negative 1 is I right there. After that, we add 1 to each side, come up with 2x equals 1 plus or minus 2i. And lastly, divide each side, divide everything by 2. Giving us a final answer of x equals 1/2 plus or minus I. All right, there we go. The second one, second problem here, B, is well set up for completing the square. And so we're going to rewrite it in a little bit more friendly format here. So y squared minus 8y, and then we're going to leave a little gap in here, equals 2. That gap, the way we figure out what number we need to add in to complete the square, well, we take our b value, divide it by 2, which would give us negative 4. Square that, so negative 4 squared is positive 16, and add 16 here. Now to keep the equation equal, we either could then subtract 16 from this side as well, or add 16 to the other side. Now let's go ahead and do that. Actually, let's add 16 to the right hand side. That's going to be more helpful for us in this problem in particular. And now one thing you do need to be considering is if your a value is 1 or not. If it's not 1, then you need to factor out the a value from your y squared and your y term. But don't factor out the y. We'll need the y squared and y to be completing the square. But if your a value is anything other than 1, factor that out and then continue on from there. We'll see some problems in a little bit where you'll have to do that. But for right now, let's continue on. So we end up with 18 equals, well, it's going to be something squared. That's why we're completing the square. So we have this perfect square over here. And you can go ahead and factor that out. And what you'll learn pretty quickly is that it is going to be half of your b value, so or y minus 4, half of that b value there. All right, so we have y minus 4 squared equals 18. Take the square root of both sides, just like we did on problem A. That gives us y minus 4 is equal to positive or negative 3 root 2. That's the square root of 18. All right, we're going to add 4 to both sides and be done. Coming up with our final answer of y is equal to 4 plus or minus 3 root 2. All right, C here. Now the numbers for C are pretty big, but we're still going to go ahead and go through and solve by, this one we're going to use factoring. So again, the first problem A, we solve by take the square root method, taking the square root of both sides. B, we solved by completing the square. We had to add in that 16 to both sides there. And now we're going to solve by factoring. All right, solving by factoring. So when we solve by factoring, we want to have it equal to 0. So we're going to subtract 1,575 from each side. And then we'll have our quadratic equation. Now it's something is factorable. If you were to take the b squared minus 4ac, the determinant, and if it is a perfect square, then it would be factorable. And this one is. You can go ahead and pause the video and check your discriminant just to show that to yourself. But we end up with x squared minus 10x minus 1,575 is equal to 0. All right. From here, we're going to take the a value, 1, and the c value, negative 1,575, and we need to find two numbers that multiply to give us a times c. So they need to multiply to give us whatever a times c is, and they need to add to give us b. So we're looking for some numbers that multiply to give us negative 1,575 or 1,575, and add to give us negative 10. And if you want to think of it as x squared and x, that's often how it will be written. If you've ever seen this little diamond puzzle before, again, multiplying for the top, adding for the bottom. And you can either just kind of go through and guess and check your way there, or you can be really deliberate and start, well, hey, if I have two numbers that are going to multiply to give me a negative, I know one of them is negative and I know one of them is positive. I also know that the one that is negative has to be larger, because when I add them together, I'm still coming up with a negative number. And so a very systematic way of finding them, it would be start with 1 and negative 15 or 1,575. Those will multiply to give me the top number, but clearly won't add to give me the next one. And so I'd start going through, and 2 isn't a factor, so 3, and that goes in there. Negative 525 times. Add up to negative 10? No. And so you can keep on going through, and 5 is going to be a factor, 7's a factor, and keep on going. I'm going to jump a little bit. I can see that 3 is going to go in there again, so 9, and that gives me, what is that? 175. So 9 and 175 still doesn't multiply to or add to give me negative 10. I'm going to jump a little bit. And maybe I'll jump too far, but I see that the 5 would factor out of that, so multiply this side by 5 and divide this side by 5, and I come up with, let's see, 5 goes into that, 3, 15, 25, 35 times, so 45 and negative 35, and so I went too far. Now this is going to positive 10, but hopefully we can catch that and pause there and go, hey, wait a second, if I had negative 45 and positive 35, those would be the numbers I'm looking for. So negative 45, positive 35, and those are each x. We found our factors. And those are pretty big numbers on this problem here, and generally you'll have ones that are a little bit smaller. But still, without a calculator, we went through and we were able to find what the factors were going to be. So I've got x minus 45 times x plus 35 gives me this here. Now, once we've factored it, that's not the end. It's in its factored form now, but we still need to make sure that we actually solve it. If I have two things multiplying together to give me 0, then one of them has to be 0. And to find our two solutions is if the one on the left is 0, then we get x is equal to 45. And we get that from setting this x minus 45 equal to 0, adding 45 to each side, and we get x equals 45. And on the second factor, we end up with x equals negative 35. there are our solutions, our x values that make this equation back up top true. Last one is using the quadratic formula. So we've got d over here, and as it stands right now, it's got this radical in it. It's not really in a usable form, and so our first step is going to be to square both sides. Okay, we're going to square both sides to get it in a more useful form. So anything, the square root of anything squared is just the stuff inside that square root, the radicand. We end up with 3z plus 6 is equal to, and now you multiply this out. Remember, this is not 2z squared plus 1 squared. The squared doesn't distribute, and exponents don't distribute like that. This is really 2z plus 1 times 2z plus 1. And so we end up with 4z squared. Let's see, 2 plus 4z plus 1. Now when you're using the quadratic formula, you want to get it all set equal to 0. And I personally like having a positive a value, so rather than subtracting all three of these, I'll subtract 3z from each side and subtract 6 from each side. That'll leave us with 0 equals 4z squared plus z plus 1z and minus 5. All right, your quadratic formula is, it depends on how you learned it, and I tend to repeat it a little bit differently than other folks, and so this I think is the first time we've talked about it in a video, but I like to break it up with into two distinct fractions, because this first fraction has a lot of information for us that we'll be using later on. So negative b over 2 times a plus or minus the square root of, maybe a little more room, of b squared minus 4 times a times c, also over 2a. Now you're probably more used to seeing it as b plus or minus the square root of b squared minus 4ac all over 2a. But I do like to split it up like this because it really emphasizes that, hey, this piece of here, this piece right here is some really useful information. This is going to be our axis of symmetry when we are graphing parabolas, and folks just tend to lose that and try to memorize it as an entirely new piece of information when you really already know how to find the axis of symmetry. All right, but there's our quadratic formula. So let's go ahead and plug in our a, b, and c values. So x is equal to negative b, and b is 1. So negative b over 2 times a, which is 4, plus or minus the square root of b squared, so 1 squared, minus 4 times a times c. Now a is 4 and c is negative 5. This is also over 2 times a, which is 2 times 4. Cleaning that up and simplifying that out, we have x is equal to negative 1/8 plus or minus the square root of 1 minus, or really plus, because we got a negative and a negative, so multiply those together, we get a positive. So plus 4 times 4, that's 16, and 16 times 5, 16 times 5 gives us 30, plus 50 gives us 80. So plus 80, all over 8. And that will continue to simplify. The square root of 1 plus 80, so the square root of 81 is 9. So we have x equals negative 1/8 plus or minus 9/8. And hey, this is going to continue to simplify it out for us. We have like terms here, or sorry, like fractions. So negative 1/8 plus 9/8, that's 8/8, which is 1. That's if we went with the plus route. We also have negative 1/8 minus 9/8, which will give us negative 10/8, and that one's going to simplify down to negative 5/4. So there's our two answers. X is equal to 1 and negative 5/4. Now we got to be sure, particularly when we have a problem with a radical back up here, that we actually check those numbers. Sometimes we'll come up with some false answers, even though we did all the math correctly. So just very quickly, let's plug them back in. We have 1 times 3z, so here's radical 3 times 1 plus 6, and that's going to be equal to 2 times 1 plus 1. And let's see if this ends up being true. So 3 times 1 is 3 plus 6, so really this is the square root of 9 equals 2 plus 1, which is 3, and 3 equals 3. This one's a solution. 1 does work. Let's also try with negative 5/4. So if we have 3 times negative, let's try that again, the square root of 3 times negative 5/4 plus 6, and is that equal to 2 times negative 5/4 plus 1? Give us a little more room. So this will multiply out to give us the square root of, let's see, what is that there? 15/4, negative 15/4 plus, and it's 6. If I return that into fourths, that's 24/4 equals negative 5/2, negative 5/2 plus 1. Continuing on, we have the square root of 9/4 is equal to negative 5/2 plus 1, and we will come up with, negative 3/2. Sorry about that. Now when we take this square root here, just out of room, we will end up with 3/2 is equal to negative 3/2, and that is not true. So as we come back up, negative 5/4 is not actually a solution. Be really careful, because we did all the math correctly. We did the solving by the quadratic formula, but because of the problem, how it was given to us with the radical and how we squared it at the beginning, we actually added in a false answer by squaring it. So just be real careful when you see this type of situation. All right, hope that helped.